Hello everyone, my name is Paul James and I'm here to present my project entitled Semantic Aware Data Warehouse Scheme for Crowdsourcing Learning Materials in Fragile Context for the case of Uganda refugee settlement. So without wasting any time, let me dive into introducing the key terminologies. In this slide, I will introduce the key concepts that frame our research. And the first one is the fragile context. We are specifically looking at Uganda refugee settlements like Budidibidi, Budibuti, and Rhino Camp. Uh, these are environments where schools are frequently disrupted and resources are scarce and internet connectivity is also intermittent. And the second one is crowdsourced learning materials, and teachers and volunteers create and share local materials, photos of blackboards, scan NGO worksheets, and handwritten lesson plans. These are mostly shared through WhatsApp and Telegrams. And then the third one is the traditional data warehouse. The standard databases can store files, but they cannot model meaning, context, or uh, pedagogical relationships. Uh, they assume clean data, stable schema, and continuous connectivity assumptions that fail in refugee settlements when we come to the refugee areas. And then the next one is the semantic aware warehouse. Uh, this is our purpose solution. It understands meaning and pedagogical relationships. It is built as an ontology driven knowledge graphs. And then the second one is epistemic trust. This means confidence that a learning material is valid, aligned to the curriculum, and currently teachers have no way to verify what they download. That is why we are going into this. And then now the sixth one, uh, the last one here, last but not least, is the offline first architecture, which is our system is designed to work without internet, and it only asyncs when connectivity appears using opportunistic batch uploads. Yes, as we can see down here. So without wasting any further time, let's go to the background of this project. The background of this project comes from what teachers do today. Okay, teachers share resources via WhatsApp, Telegrams, and groups, uh, and but files get buried in chat history with no organizations. What is missing in this is no understanding of the file context or content. And then there's no verification whether the file is actually curriculum aligned or has quality for this kind of refugee based system. Because in most cases, teachers just write, they even use the normal curriculum to teach the refugee areas or refugee students which are already stressed out, so it is not actually working out for them. And then there's no offline search or retrieval. They are always designed so that they make sure that they so that they make sure that actually most of the people who actually design most of these things, they assume that those refugee areas there's internet, and then there's no trust framework among that. And this all results into what we call digital chaos, crisis of epistemic trust, and then teachers cannot reliably find or use crowdsourced materials. Uh, EdWAS, a scalable educational data warehouse as a service, is one of the uh, literature reviews that we went through uh, after discovering the background of this project. And this one deals with the multi-tenant Snowflake scheme for academic data maths. And it uses the extract transform load using the Haddock map, reduce, and then all of queries on the Hive or HDX. And this one, the results achieved here it allows multiple universities to share a cost-effective cloud warehouse, constant time data loading regardless of the file size. And then the architecture limitations here is that in most cases here it requires universities to upload data in a rigid CSV format. Uh, data cleansing left as a manual processing. The schema limited to student performance, teaching quality, and student counts only. And on the other side, ours we are actually moving into very many file formats. And then the context here or the data limitation is it only tested on theoretical university data, no mention of handling of unstructured data like the PDF images or videos designed for structured academic records only. So as I said, is in the CSV format. And then the next one here, when we come, is the ELI one, the semantic. Uh, sorry, is the ELI one semantic model for e-learning integration. This one uses the all ontology for e-learning data integration, the SWRL reasoning rules, predictive modeling, and time series forecasting. And then the result is successfully semantize data from multi-learning management systems like the Moodle, the Open Universities, and the fit predictive machine learning models for students, grade forecasting, and behavior classification. Now, ontology must be manually on the system architecture. Limitation is the ontology must be manually designed and extended for each new data as source, and it requires expertise in semantic web technologies, and reasoning can be computationally expensive. And then the context or the data limitations is it is tested only on software engineering courses from one university, that is Malaga University in Spain, and then the Open University dataset. Uh, and in this case, the Open University dataset may not generalize to other disciplines or institutions. Yeah, and then the next one here is AGNI, that is attentional graph convolutional networks for MOOCs. And this one deals with a heterogeneous information network uh, as a model, and then plus the meta path. Okay, there's one up there we left. I didn't explain it, but let me just come to this. Yeah. So this one it also deals with the graph convolutional networks, and then the graph attention networks, and then the matrix factorization, and then the uh, it comes alongside with outperform the state of the art methods on the large public mock-cube X dataset. That is a dataset uh, file, and then it is more precise recommendation and course outcomes. And then when it comes to the limitations, there's a complicity of combining multiple techniques like the GCN, the GAT, and then the matrix factorization may increase training time and resource requirements, and then the underutilizes the dynamic nature of learning processes. And then the data limitation is evaluated. It is only evaluated on the Mark CubeX datasets, that is the Chinese MOOC platform, and may not generalize to Western platforms or African context or the non-Chinese, in simple terms, language context, and focuses on the knowledge concepts. Yeah, and then the rest follow. Uh, Let me come directly to our problem statement. Our problem statement is divided into computational and then the domain application problem. For the domain application problem, we are talking of the specific context, which is the Uganda refugee settlements. In Uganda, they are, uh, mm, oh, sorry. Yeah. In Uganda, uh, there are over 1.5 million refugees, primarily from Sudan, Congo, Somalia, South Sudan, and then this one use the formal schools are frequently disrupted. In this case, the formal schools that are provided for this kind of refugees are disrupted, and then the teachers rely on locally sourced crude materials, which means they just come in with what they think is right, not what has been aligned for that system. And then when we go to the computational level, it is divided in two layers. Layer 0 is the epistemic trust and educational resource alignment, and then for the layer 2 it uses the weak supervision from crude source metadata, and then the large language model assisted extraction, and then the level 3 is the semantic context based retrieval and entity linking, and level 3 is the highly unstructured multimodal educational artifacts. And then level 4 is the offline fast bunch synchronization regime. And level 5 is the extreme low bandwidth hardware constraint, semantic drift constraint. And then level 6 is the decentralized mobile edge ingestion into access control warehouse. And level 7 is the graph machine learning and symbolic ontology driven model families. Now in the conclusion, the relational databases suffer catastrophic schema mismatch, and then in this case this is where the knowledge graph infrastructure is required. For the research questions and objectives, uh, there are a few of the research questions that we had to answer here. This include how can we systematically extract structured pedagogical entities from unstructured, noisy, crude source educational artifacts in low resource settings. And then the next one is how can an ontology driven knowledge graph represent relationships between crude source materials and formal curriculum standards. And then the next question is, how can graph neural networks provide accurate context-based retrieval under extreme graph sparsity? And those are the questions. And then we had to answer those questions by designing and evaluating a large language model assisted semantic extraction pipeline for noisy multimodal educational context. And then the next one is the construct an ontology driven knowledge graph schema mapping crude source artifacts to pedagogical concepts. And then the third one is implementing and benchmark the graph neural networks for pass and out of distribution educational graphs. And finally, embedding cryptographic privacy and epistemic trust mechanism into the system for privacy. And we come now to the research contributions. What did this research contribute to? An offline fast semantic aware data warehouse architecture designed specifically for fragile contexts, and then an ontology driven knowledge graph schema for crude source educational materials, pedagogical nodes, artifact nodes, and some semantic edges. And then the benchmark graph ML pipeline for sparse uh, educational graphs with out of distribution uh, evaluation. And right now, that is the percentage that we have achieved when we train the model. And then there's a privacy by design framework with a cryptographic uh, anonymity, differential privacy, and epistemic trust mechanisms. This is the methodology, and then the methodology in this case, we collected the data and then we actually import that data into the system to extract the plain text. Since BAT does not understand the PDFs or any other file extensions, it understands the plain text format of the file. And then we trained the file and evaluated it. After training it, we had to go into tokenizing using the LLM. We tokenize the all the text. Like for example, when the user probably is texting or probably uploads any file that contains like hello world, how are you doing, it is going to tokenize that text into separate words, and those ones are called tokens, into separate tokens. And then those tokens now are converted into numeric IDs, and then LLM receives the IDs for those words, and that is what it will understand. So anything that comes to that, it will convert all the words into the ID and back to the original message. And that is how it will actually understand that this is such and such a subject and it belongs to such and such environment. And then we trained it using the data sets, that is the BAT, and then supervised, of course. And then finally, with when we test it in something like this. So we load the VAT model, and then we try to make a prediction. So for example, we say hi, how, and then probably miss something out, and then we put you. So it is going to make a prediction that yes, this one is trying to greet me. So therefore, it is missing the word R. So it is going to put hi, how are you? That is now the mask it is just going to put, because the mask wasn't there, but then to predict, yeah, this is what's supposed to be there. And that's why whenever we put something on chat, even if it is wrong, chat will always give us something. That is the way it understands. uh, um, Yes, and then now for the dataset description, we got a total of 111 PDF documents from the NCDC, and then the educational levels, as we can see here, we have A level 48 files, lower secondary is 52 files, and then accelerated is 11 files, and then the subjects is 33 subjects. Document types is syllabi, and then the teacher guided, and then learners books, and then the curriculum frameworks. And yeah, that's what was all there. And then the average pages is from 30 to 50, and sometimes it surpasses to 100. So this is just the average. And then the text quality is clean and then extractable text. And then the context features is learning objectives, assessment, guides, and educational terminologies. And then when we understand here the subjects, examples of the subjects included this: biology, chemistry, mathematics, history, geography, economics, language, arts and design, and then vocational studies. And then uh, use case are the training subject classification models. Uh, we are going to use all the subjects to train the supervised learning classification model of BAD. Yes, and then we explore the data after collecting that data, and as we can see here, it is a 3-in-1 uh, graph, which is having the pie chart. It is having the bar chart, and then it is having the line, the bar graph, also the horizontal bar graph of representing all the 20 subjects and the files allocated to that document count. And then the education distribution by education level, which down here we can see the lower secondary leading with 52, then A level leading with 48, and then accelerated curriculum with 11, which we can see here. It is really literally small. That is the data set actually that I found online. And then this one is the subject versus the distribution heat map. Now this one here, the darker side, the darker shades indicate higher file counts. As we can see here, the one with the higher file count here is 8, and it is taking the count of art and design. And then and it is of the lower secondary actually. So and then the lower count, the lowest count is the lightest of all, which is 0. Where you see 0, that is the lowest. Yeah, and we can see all the subjects that we analyzed here alongside this. Yes, and now we come to what we call word cloud. Now word cloud is just to understand us that this the exploratory data analysis was actually a success, in a way that we have to understand from each of the PDFs that have been provided what is inside it. Like for example, when we come to probably biology, okay, biology here. In biology, it is showing us biology up, and then it is telling us that there's introduction, cells, and then there's insects inside this biology. It is having also senior, it is very many things. So literally, this one is just to give us the insight of that subject, what is in each of the subjects, what is supposed to be, what do we expect the AI to learn from the subject. Yes, so now after training the models, this is what we came up with. The highest definitely was the highest here was the ensemble. We combined the Roberta and then the Electra and then the BAT. Okay, but For some reason, I didn't pick it as what I was going with. Why? Because because Roberta was a bit unbiased. It was overfitting for some reason. So that is the reason why I decided to ignore all this. Electro would have been also among the best. Why? Because it is having higher accuracy than BAT, but for some reason it is not good for our project because it is too light. It is too light. It is not going to get deeper meaning of the subjects. Therefore, I decided to go with BAT for now. Otherwise, I would have taken Rowata because this one here is actually a more accurate version of BAT. But for some reason, when I was training, it was overfitting. It wasn't giving me accurate files. I would train it like 3 to 4. I trained it like 3 to 4 times, and then it was giving me either low or high, so it wasn't giving me consistent results. And unlike BAD, which was giving me 88%. Yes, so I decided that's why I highlighted it green. And then when I come to the to viewing all these results, of course, uh, I tested them directly during the training for all this. And then as we can see from the green side, in most cases, this one is leading in almost everything. But that is why I told you I decided to go with but other than the robot. It wasn't giving me what I actually expected of this. And then the distill but would have been also a good choice, but I decided to go with the but here. So that is what I've actually decided to go with. So now the proven rewardness of noise and the context. The reason why I chose that is BAT was fine-tuned on 111 Uganda NCDC curriculum document, and I achieved this kind of accuracy and demonstrated 90% accuracy on the novel and syntax, and then the optimal trade-off for low resource environment. This requires a lot of RAM, of which it is actually too heavy. When I run it, it is also going to slow down. It is going to pull down my resource of the PC, and my emulator will make my PC crash or slow. And then the distill bat is lighter but less accurate. And then the bat sits at the sweet spot in this case because of the good accuracy and its acceptable resource footprint. Because why? But it is applicable when you are dealing with the offline fast comp compatibility. But model can be cached locally on mobile edge interface resource interface runs. Uh, okay, mobile edge. Then the interface runs entirely offline after initial download, and then no continuous cloud connectivity required. And then the transfer learning from large corpora. Now the pre-train on it is pre-trained on 16 GB of text, uh, books, Compass plus Wikipedia. So that is why I actually had to fine tune it to this because it has been Wikipedia having the largest source, and then the books Compass, which I actually indicated somewhere there for unsupervised. Yes, now for the supervised, it is fine tuning on this. Yes, so that is why I actually chose the bat in this case. And now for the limitation, okay, LLM extraction, there is a hallucination and then the semantic graph, and then the impact of this case is artifacts mapped to wrong ontology nodes, and then the current mitigation is the confidence thresholds plus human in the loop verification. These are the limitations of the faced by the project itself. And then the graph neural network requires rich edges. It requires rich edges. That is, it fails in the call start, and then the impact is the poor recommendation in the new camps, and then the manual uh, curation for new camps. And then the button Roberta models. The weakness here was the large memory. Okay, it requires from 400 to 470 MBs when I was downloading actually the model, and then it cannot run on low-end phones, and then it uses the distill or Albert for mobile. And then The edge device is 1 to 2 GB RAM typically, and then the memory. Uh, the impact here is the memory exhaustion, and the hub crashes and quantized embeddings. And then the ontology is the evolution breaks backward compatibility. And then the impact is the historical analysis difficulty, and then manual versioning is what we mitigate. Yeah, and then the data set is only 111 files with the accelerated level underrepresented, and that is why at some reason we are going to find difficulties in understanding if this one is accelerated or probably A level. And then the models may not generalize all subjects, stratified sampling, uh, collect more data. So in conclusion, what we did, we abandoned rigid legacy dimensional models like the Kimball star schema, and then reconceptualized data warehouse as an offline fast semantic knowledge graph using, and then we use the large language model assisted data engineering for noisy crude source context, and then apply the graph representation learning for retrieval, and then embedded privacy by designing the cryptographic anonymity and differential privacy. Now, for now, we are still in differential privacy, not cryptographic. Uh, what we achieve is 84.14% accuracy with BAT, and then out of distribution robustness across refugee demographics, and then epistemic trust through semantic evidence generation, and then the offline capable business intelligence interface for teachers. And then the future works here, we are going to we are planning actually to implement the psychological psychosocial support ontology, that is the expand knowledge graph to include trauma informed educational frameworks critical. This is actually critical for refugee children but absent from uh, standard curriculum models. And then the next one is address addressing the emotional and psychological needs, not just academics. And then multi-agent generative system went also to transition this from passive semantic retrieval to active generative intervention, and deploy autonomous agents that query the graph, and then dynamically synthesize hyper-localized lesson plans adopted to individual settlement constraints, and then the federated learning, which comes with enabling model improvement across settlements without centralizing sensitive data, and then preserves privacy while benefiting from collective learning, and then it is also going to bring about the being critical for diverse refugee population in Uganda. Yes, thank you. These are my references, which will be in the PDF, and then acknowledgement. Of course, God first in everything, and then I would like to also acknowledge Mr. Michael Chizito and Mr. Galwango Marvin for supervising this project, and the teachers and the schools that actually gave us the way forward to pass through their schools to give us the information that we need about this learning environments and how they actually conduct their teaching plans. Thank you so much.